Hello world, Calc Programmer 1 here. Today I wanted to do a quick tutorial on setting up OpenRGB to control E1.31 lighting devices. If we search Google for E1.31, we can find that it is an open industry standard protocol for controlling lighting devices over Ethernet and Wi-Fi networks. It can control all sorts of different lights and is used by several different open and closed source projects to communicate lighting data between different software. It's very popular in the Christmas lighting community, and it's also used for stage shows and other sorts of lighting projects, but we can use it for OpenRGB to control LED strips wirelessly. If we go on my GitLab wiki page, I have a page for E1.31 configuration in OpenRGB. Basically, this involves writing a file called e131.txt placed in the same directory as the OpenRGB executable. You can basically copy this block and then edit it to fit your needs. A list of parameters is given in this table, and then some additional parameters to configure a matrix, which is a two-dimensional grid of LEDs, is also provided. But we're only going to be setting up a single LED strip in this video. The firmware that we're going to use is called WLED and is available on GitHub. And then we're going to use esptool to program our controller. And so if we go over here, we can see the controller. This is the controller we're going to use. It's an ESP8266, which this particular board is called an ESP01. It's the cheapest ESP8266 board out there, and it has a few drawbacks. The main one is that it doesn't provide a 3.3 volt regulator. So if you want to power it off of a 5 volt power supply, which is what I'm going to use, which is this tablet charger, then you have to provide your own regulator to get 3.3 volts for it. I've actually built a little breakout board for it that has such a regulator, so it takes 5 volts in, and then the LED signal comes out on this connector. All this breakout board does is provide a 3.3 volt regulator and some wiring, nothing else. It's covered in electrical tape because I wanted to use it outdoors, and it's run Christmas lights at my house before. And then to program it, I'm going to use this ESP01 programming module. These are available on eBay, and you can basically get them from here. They have a block connector where you can connect the ESP module and a USB serial converter chip. They're pretty cheap. Not all of them are actually configured as programmers though, and mine was not. So I actually had to do a little modification and short out the programming pin. I think it's a GPIO, it's either 0 or 2, that causes the ESP to go into boot mode. And I shorted out with a resistor. So I'm going to plug the ESP into the programmer, and I'm going to plug that into USB, and then come back over to the computer. So the first thing we're going to need is esptool-gui. You can get it on GitHub and download it from here. I've already downloaded it. And then the next thing is WLED. So we can scroll down. Here's a link to the wiki. We'll go there. And then we'll scroll down even more, and here's where it says, I just want to use WLED. We'll click that, and then we'll click here where it says latest binary. That takes to the releases page on GitHub. Now, I would recommend checking out this wiki page. What binary should I use? I'm using an ESP01, and the problem with this, another problem, is that it only has a 1 megabit flash. And so for this board, it's best to use this binary that has some interfaces disabled, these interfaces here. This allows wireless updates to continue working. So you can upload or update the firmware wirelessly on this if we use this 1M OTA image. And that's what I'm going to do, because I don't care about Alexa or Blink or HughesSync or infrared. I'm not using any of that. All I'm using is E1.31, and that is built into all of these images. So we'll go back to the releases page and download this 1M OTA.bin. But again, I've already downloaded it. So I'm going to go here into, we'll go back to here, esptool, and here's that image that I've downloaded, the 1M OTA. And then we'll click esptool-gui, run that. And so it will detect your COM ports. I know COM1 is a hardware port on my motherboard, so I'm going to use COM4. It has to be the USB port. Leave baud rate alone, that's fine. We'll go to Browse and then Desktop, and that's where I've saved the WLED image, so we'll just open that. And now I'm going to just click Upload. And as you can see, whenever I click Upload, the blue light on the module starts to blink. Most modules have this. Maybe some modules won't have a blue LED, but most do. And it should blink whenever it's being programmed. You'll also see the dots moving on esptool. That means it's working. So now we just wait until the flash is loaded. And as this is happening, you should probably have a device with Wi-Fi ready to go. Because this thing is going to broadcast its own Wi-Fi network, and we're going to have to connect to it to set it up. So I'm going to use my old phone here. Just have it waiting for when the ESP does show up. So now the ESP is done flashing, it's loaded. So now it should start broadcasting its own Wi-Fi. And yes, we have here Wi-Fi called WLED-AP. So I'm going to connect to that. And then the password is on the wiki page here. If we go back to WLED and go to wiki, and here's the setup. So it says use a Wi-Fi device to connect to the access point, WLED-AP, using the default password WLED-1234, lowercase. So we need to type that in. So WLED-1234. So show password WLED-1234, and I don't know if that's coming up on camera or not, but yeah, WLED-1234. So we're going to connect to that. Obtaining IP address. Connected. And so this obviously won't have internet, we're just connected directly to the device. So what we need to do now is open a browser. And then it wants us to go to 4.3.2.1 in the browser. 4.3.2.1, go. And so you should be greeted by this page, welcome to WLED. And then you'll have Wi-Fi settings and to the controls. So we want to set it up to communicate on my actual Wi-Fi access point. So I'm going to go to Wi-Fi settings, and then that takes you to a page with Wi-Fi set up. So it wants your network name and your network password. So I'm going to go ahead and enter those in off camera and then tell it to connect. So now I've entered in my Wi-Fi information, and so I'm just going to connect or click Save and Connect. And now it says Wi-Fi settings changed. Please connect to the new IP. And so now the fake access point goes away, and I should be able to connect to it from my computer. So I'm going to get the IP address from my router here. And now it's working. So I've taken it away and now brought it back. And so it showed up on my local network as 192.168.4.14. And here it is showing up on my browser, and I can connect to it and control it. So now, if we go back to the desk here, this isn't very useful because it's not connected to any LEDs. It's still in the programming device. So I'm going to unplug that and then disconnect the module. And so I've already mentioned that I made this breakout to connect the LEDs. So we'll connect this to the breakout. And then this is just a tablet charger, 2-amp tablet charger with a barrel jack at the other end, so it's 5 volts. So we'll plug this end into AC. And then we can plug the other end into the device. Now, this is powered up on its own. I'm going to take a strip of WS2812B LEDs. This is a 40 LED length, and connect them to my device. And so they've lit up. And so I'll just bring these in frame a little bit. And so here we have the control panel for WLED. So we can click different colors, and you can see the lights change. There is a slight delay, but that's actually from my camera setup, not from the device itself. It's updating pretty much instantly. And actually what we can see is some of the lights aren't lighting up, so we haven't fully configured the lights. So we need to go into config and then do LED preferences. So I actually have 40 instead of 30, so put in 40. We can put the maximum current in, so I'm using a 2-amp tablet charger. And actually I did that, I'm using my number pad for switching scenes, so that's why that happened. Leave max current per LED alone. Color order, if you're using 2812B strips, it's GRB. If you're using WS2811 lights, the strings, those are RGB. We're just going to leave it at GRB order. And then I'm just going to leave everything else at default and save. And so now you can see even all the lights are lit, even the last LED is lit. And then we can go back to the home page. We can increase the brightness. And then we can change colors. And all LEDs should be changing. So white, red, green, blue. So all the colors are working, and they're all in the correct order. So now let's configure OpenRGB to work with this. So we're going to leave this open, but then I'll go into my desktop and select OpenRGB. This is a very recent BuildBot build from GitLab. It has a few extra E1.31 parameters that aren't in 0.3. I'm going to delete my existing E1.31 configuration just so I can demo setting it up from scratch. So I'm going to right-click, New Text Document, and we're going to call this E131.txt. Open it in Notepad, and then we'll go over to the wiki, and I'm just going to copy this default configuration here and paste it. We'll rename this to WLED strip, and then number of LEDs, we'll change that to 40. Start channel, start universe, I'm just going to do 1, and type is linear. We'll save. And actually, WLED also requires a keep alive, and that's a new addition. So as we can see here, keep alive time, if non-zero, this will continuously update values in milliseconds. Let's copy keep alive time and paste that in here. Equals, we'll do 1000. So every 1 second, OpenRGB will send an update to the device, even if there are no changes. And that will keep it from reverting back to its default configuration, which is something WLED will do if you don't keep updating it. This RGB order, that's not even implemented right now, so we can take that out. So there is our configuration. Now the last thing we have to do that I forgot about is we actually have to set up WLED to accept E1.31 input. So we'll go to Configuration, Sync Interfaces, and go down here to Real Time. Network DMX input is going to be E1.31, so leave it at E1.31. We'll go ahead and check multicast because OpenRGB only uses multicast at the moment. Start universe, we want 1, and DMX start address is the same as start channel, that's 1. So that should match up what we put in E1.31, so start channel and start universe, 1, 1. That should match what is in here, 1, 1. Note if you're going to be setting up more than one device, one universe can have 512 channels. Each RGB LED takes up 3 channels because red, green, and blue are 1 channel each. So if you're going to use multiple devices, you'll have to space them out accordingly. So you can calculate the number of channels used by multiplying the number of RGB LEDs times 3, and then you can divide by 512 to get the number of total universes that your device is using. And then you want to configure your additional devices with a high enough number that they don't overlap. But that's a topic for another time. We're just configuring one device for today. So we'll save, go back to the home page. I'm going to turn on peak, which shows basically what the output on the strip looks like in this little bar. And then now we should be ready to start OpenRGB. So we'll start it. And what you should see is when OpenRGB starts up, the lights here should turn off because the default color on OpenRGB is all off. And something isn't working right, so let's go back to our configuration. This timeout is the amount of time that if it doesn't receive an E1.31 packet, it will shut off. Let's increase that to a larger number, like 10,000, so that it'll wait 10 seconds. And then also let's save. And then let's also go ahead and power cycle it, just to make sure that all the new settings are applied correctly. So I'm going to unplug the controller and plug it back in. And now it looks like the E1.31 receiver is working on WLED because all the lights have shut off. If we refresh our browser, it comes up and says WLED is receiving live E1.31 data. And that means that the command that OpenRGB is sending is overriding the built-in effects that can be set in the web page. Let's go back to OpenRGB. So let's go ahead and pick a color. Let's do blue and click Set All Devices. And now everything's blue. So you can see my fans, my Razer Chroma base station, even my mouse, everything has changed to blue. Then we can also go ahead and change to green. And to red. So all of the devices, including WLED, are synchronized with OpenRGB. So now let's go ahead and start the SDK server and minimize that. And then we can open up Keyboard Visualizer and click Connect. And so now all of the devices are running the animated pattern from Keyboard Visualizer. I think the rainbow effect is actually easier to see with the lights on, more dramatic. So I can see the pattern is moving and that it's synchronized. If I increase the speed, you can see that it's increased the speed on everything and that everything is synchronized. The Razer gear, the Corsair controller in my case, and the WLED strip are all perfectly synchronized. And so that is basically all I wanted to show you, how to get WLED working with OpenRGB, and that's about it. So thanks for watching this video. If you have any more suggestions on videos and tutorials you want to see regarding OpenRGB and anything that connects to OpenRGB, please let me know in the comments or on the OpenRGB Discord server. And other than that, thanks for watching and have a good day. Thanks.